Question 4, show that this function is an increasing function for all real values of x. In other words, it's always increasing. So when I drew this on the website, this is what it looked like, right? And it just shoots off to infinity there and shoots off to minus infinity. You see there, it's always increasing, isn't it? Okay, the gradient is always positive. Okay, the curve is always going up. Even at that point there, it is increasing, isn't it? It's positive. It doesn't become flat. It just keeps on going. Okay, so this curve hasn't got any stationary points. Okay, that isn't a stationary point. Okay, it's not what you think of as a point of inflection because it's not flat there. Okay, it's always positive. Okay, so the gradient here is always greater than 0. Well, we've got to show that that's the case. Well, if I look at the function f of x and I work out the gradient f dash of x, okay, and if I differentiate this, I get 3x squared plus 24, yeah? And the 3 disappears. Now, to show, okay, is different to actually finding a range of values, as in the cases before, okay? So we've actually got to show here that f dash of x is positive for all values of x. But if we just look at this here, this setup here, we can actually prove that this is always going to be positive, because if you think about it, x squared is always positive, isn't it? Or it could be 0, okay? But we can say that, can't we? X squared is always greater than or equal to 0. Because if you think about it, when you square something, when you square it, it's no longer negative, isn't it? It makes it positive. So even if x is negative, okay, when you square it, when you times by itself, it becomes positive. So it can only be positive. It could equal 0, of course, if x was 0. But if x squared is greater than 0, well then if you're going to times it by 3, okay, and then just add 24 to it, well if I'm going to add 24, well it's always then going to be positive, isn't it? Okay, because if I'm adding 24 to something which is at least 0, it's going to be greater than 0. So therefore f dash of x, okay, is greater than 0, and it's important then to put for all x here, okay, as the question is sort of asking us to establish. This is the case here, isn't it? Since x squared is greater than 0 for all x, isn't it? And that's the case here for all x. Okay, so we've shown that f dash of x is greater than 0 for all x. In other words, the gradient is always positive. Okay, so therefore function is increasing for all x values.